Thank you. I didn't know I had the power to break the the meeting, but there you are. It's the cookbook fault. So I was about to say that we evaluate during the Fair Plus project. We evaluated this Fair cookbook in terms of its utility and its value, and we use three axes somehow. We look at the cookbook as educational material because within the project we had a fellowship program where we had fellow from academia and industry, and they actually not only reviewed and used the cookbook to make data fair, contributed to it, and obviously we had the confirmation that they could actually learn the things that the recipe was supposed to teach them, as well as obviously it's a very steep curve for in some places, but we know fair it's technical. When people say, oh, I don't understand, it's complicated, well, this is a resource for fair doers because fair is technical, require technical expertise. Anyway, we also use it as a practical guidance to improve the task within the organization. That really helped. But we also tested if that was also helping in changing the culture within the organization and identify investment area in the organization. And we work specifically with 4 of the industry participating in the project, with Johnson, Boehringer, AstraZeneca, and Novartis. And obviously, because everything happened behind a firewall, as you know, what we heard was, yes, we managed to, convince, for example, our managers that we had to invest in that technology to make the data more discoverable, as well as also they reported that there was a very positive effect of the different real recipe in terms of operationalize the specific steps. So we believe it's working. We tested it's working. So if you want to test it for yourself, feel free. Like I say, it's an open resource. If you want to learn more about the content, the building our experience in testing it, there is a preprint which is in Zenodo, and an article it's available will be printed very soon. It's in press. Okay. With this, I'm going to move to the second resource, which is fair sharing, which is about all disciplines. So you already heard in this meeting, it's about ontology, which is a kind of standard. And you already heard that there are many standards for many purposes. Resource level discovery interoperability standard, core level discoverability, deeper standard helping to understanding what's the data and the metadata, how an experiment is done, what data file it is. So the deeper you go, the number of standards explodes, and there are many for many disciplines. If we want to look at number, and we look at the fair sharing resource, which I'll introduce shortly, there is over 1,653 standards classified according to identify a schema, checklist or guideline, because people want to report the same information. There are terminology encompassing control vocabulary, thesaurus, ontology, so on and so forth, different level of quality and quantity. And there is format, conceptual model, schema, exchange format, and etc. And some of them are completely independently built to work on their own. Some are actually have been built by the community to work in combination. You have specific format that requires specific ontology for representing and described information. So it is important to understand what the standards there are, how they are related, who use them. And when we say who use them, it's not just about which organization use them, but also what data resource it's out there. They use them, and therefore there is corpus of data sets out there that are annotated with the standards. And who is recommending them, and should people recommend them? And the answer is yes. So this is somehow what fair sharing is trying to do. It's a registry where we describe these standards. It's different from an ontology browser. It's not ontology browser. We describe the ontology, we describe the model, we describe the format with the help of the community to understand what the user is, what the relation with another standard is. We try to understand and describe the database and understand which standard the database implements. And we also try to understand what data guidelines and policy are out there that are recommended standard and databases, because it's important to recommend them and widen their use. and everything gets connected in terms of a graph. The information is connected. So the mission of fair sharing is to promote the value of standard, including ontology, as well as database and policy. Standard, as Baron says, really underpin the FAIR principle. And so it's very important that all stakeholders involved in the data life cycle or research data life cycle use the standard. But we also want to assist the producer of the standard, of the ontology, of the model, of the format, to make sure those are discoverable outside their direct domain of use, because there are standards that can be repurposed or people might end up reinventing if they don't know they exist. So having a registry that encompasses all disciplines, it certainly has been useful. So we work not only with the consumer of the standard to make sure they find them and they use them, but also to the producer of the standard and the databases to make sure that they become visible to other people. This is just in terms of fair sharing in number, in content, what we have and how much has grown, and has grown in terms of discipline coverage over the years. So I wanted to obviously try to give some insight in what we have that's relevant to material science, but it's going to be a bit tricky because what we have done also is classifying the content according to the disciplines. And as you can imagine, if I say material science, I might be too specific. There are also other resources under engineering science or even under material engineering that would be relevant to you. So I'm just trying to give an insight on the fact that you can then search the content according to your area of interest. What we are obviously after, and I've heard a lot of standards that have been presented yesterday actually, that we don't have, and I immediately mentioned them to our curation team because we would like also to make a call for the people in the audience and in your community to make sure that if your standard is not registered in fair sharing, please do register. It's very simple. If not, contact us, we will help you. What we do, and this is only a snapshot of part of a record that describes a standard, that's an ontology for matter transfer, a matter transfer ontology. It shows that the way we do describe the standard is to explain its life cycle. Is it mature? It's been deprecated because there are many standards which have been deprecated or superseded by others. Is it uncertain? Maybe it's been developed but never used, or it's in development so that, a community has put a flag in the land and it's working on that area, it's looking for collaborator. And then we put other metadata information about that standard, including an ontology, which is as a license. Is there a maintainer? Is there a contact point? Is there any other related standard? Is there a database that implement the standard? How can I access the standard, their example, and so on and so forth. I also wanted to mention that the content in fair sharing, there is a UI, everything is manually created, but it's machine readable. So fair sharing, it's fair as a content. We have all this technology that make sure the content is discoverable by machine as well. And this is very important because our content power third-party tools, data management planning tool, but also fair evaluation tool. You heard from Romain that there are over 20, actually 23 evaluation tool, and many use fair sharing because when you want to assess if a standard or an ontology, for example, it's truly exists, which has been used by a community, you use fair sharing as a registry for assessing that really truly exists. It's a sort of authority for content, and Romain also pointed out to this apple-to-apple workshop that the EOSC Fair Metric Task Force has done, and that really also, that report also explained the role of fair sharing, registry like fair sharing in this fair assessment process. I also want to show very briefly that we work with different organizations in all disciplines to indeed shows what type of fair profile they are. Are they using standard? Which standard are they using? Are they use database? Which one are they using it? And this is quite important showing these profiles because it really shows the level of endorsement and uptake of the standard by a community, by an organization. A very simple example example, given that again we talk about ontologies, the work we've done with the Pistoia Alliance, which you already heard mentioned by Martin Romacher, which is a pre-competitive initiative bringing together pharma and other company in the life sciences. We are working profiling some of the company in understanding which type of ontology they're using internally. And somehow this gives us a snapshot of the semantic and syntax standard that are used by certain pharma at a given time or certain unit within a pharma. And for example, here, we realize that two companies were using indeed the same ontology, the same disease ontology in this case. So that really helps because also promote collaboration and use of common standard where this is possible. I'm finishing with an example that shows that nobody can build a registry like FAIRsharing, what my group sustain, without the help of the community. So working with the expert in the community across all disciplines in making sure that the content is rich enough, and then we create material that help other users to use FAIRsharing, it's important. And this is one of the work that we have done as part of the EOSC, funded also seeded by EOSC. It's the creation of a FAIRsharing community champion program, where we have at the moment a short number of champions that are focusing on different domains that helps us curate the content and create educational material. We have an initial set of educational material, including one that helps explaining what the standard is, how to fund it, how to use it. And probably we're going to go and explain a different type of standard, what they are, and go a bit more deeper also to help user, like I say, endorsing and uptaking and using the standard. And with this, I leave you with the contact information. I've also shared the slide in your folder, and I take any question, and thank you very much for inviting me.
Thank you very much, Susanna, for this great presentation. Is there any question from the audience? No question. Let me see if there are questions. Well, actually, maybe just comments. I think it's great that you presented the FAIR Cookbook, because I think it's a very valuable resource for FAIR. I mean, right now, FAIR is more high level and seems to be more academic related. However, it also must be practical. And the FAIR Cookbook is actually a nice way of making things really handy, so that you can start considering things. So I think that's something that should be promoted, and also in our community, in the different companies, to say, okay, maybe look into the resources that are there for your FAIR journey, and maybe add some more in the cookbook so you can share with others. And the same thing, it goes for FAIRsharing. We need to start an OntoCommons community, because I think there are few standards and few things we need to share on FAIRsharing. So we're going to work toward that at some point, and we'll need your help.
Thank you, Jan. And there are two hands up. I don't know if they're related to...
Hands up, yes. So I don't... So there's Tommi, and there is another person.
Alex.
Name. Alex. So if you don't mind, Tommi, Alex first, ladies first.
Okay, I used the opportunity. Yeah, thanks for the interesting talk. I like the tools what you have, and like you said, it's a bit driven by biosciences, but we in materials we will have to catch up because there's several comments coming, and what is really promoted by the AMI 2030 is sharing materials data, and obviously they need to be fair, because like we learned in the morning and throughout the day, it's not it has to be done. So what we discuss quite often is like, how can SMEs join? Yeah, so I think there is some educational material where you can tell them to do the data just in a different way, do something different and whatever. And I think this is where we come in, because we start the re-education and the rewiring the brains of our materials colleagues. It's a very interesting work, because they did their job well. They do production for 100 years. There's products out of the market. And what we try to do is to bring in what you were teaching and other people as an enabler. It's very, very important to do the data, correct. Because whenever we look into operability, so whenever we look into maturity, they have good people, they have good tools. And then you drill down, so what you do with your data? What do you do with your process? Well, we have one. Did we ever document it? Is that fair? No, it's not. So I think there's a lot what we can learn from each other and give to each other. And of course, I'm really excited to explore your educational material. As I can see some gems popping out here. So yeah, so thanks a lot for your contribution.
You're welcome. Thank you.
Thank you. Tommi?
I will be slightly self-serving because I will address this in my talk, but from what the architecture that I see in your designs, do you see a role for crosswalking between the ontologies and the basically also metadata schemas, different information models that you have? If you host a lot of different ontologies or other semantic resources, I would imagine a service that bridges over those would be of high value.
Absolutely. And I'm typing as I'm talking, but I can't find it immediately. I should have added what we also have as a record. We also register crosswalks. We have already a couple of crosswalks in FairSharing. So like I say, in FairSharing, we don't map the terms because we don't have a browser for the ontology. It's a record, but we register a crosswalk because we don't want people to repeat if a crosswalk has already been done. So we do have those, if that's what you mean. And I'm very happy to continue the discussion with you and fair call for EOSC.
Thank you. If there is no question, I propose that we move to the next talk, which would be the talk given by Pascal Flohr from DANS on fair impact. Pascal, the floor is yours.
Thank you. Sorry, it's asking me to update, which I'm going to ignore. Doesn't seem like a right moment. Okay, can you see my screen?
Yes, we can see your screen now.
And can you still see it correctly?
Yep.
Okay. So yeah, I'm going to introduce the Fair Impact project to you so that hopefully you can see where there are relevant parts for what you do. This is project. It's coordinated by DANS, so that's the organization I work for, although I'm not involved in the coordination part, I must say. But it's really very much a consortium of 28 partners and affiliated entities from 10 different countries within the EU, as well as also partners and associated partners from the UK. And you can see the project here in a nutshell. So as I mentioned, the different partners from the different countries. And this is an EU-funded project. You can see the call number there, but what's important there is that it's EOSC call, so it's addressing FAIR in EOSC. That's the idea. Building on previous project FAIR, as well as other relevant projects and initiatives, and with the aim of expanding FAIR solutions across EOSC and across Europe and beyond, ideally. So it's a 3-year project. It started last year in June, so we're almost a year in, which is a bit scary. But it's also what's important is that this is a coordination and support action. So, and I will show you in the next 10 minutes or so which mechanisms we have for this coordination and this support. So a lot of text here, but this is the overall objective, which is to realize a fair EOSC, so an EOSC of fair data, fair services, and to do this by supporting the implementation of fair enabling practices across different scientific communities and across different research outputs at different scales, so from institutional to national to European level. And this is the idea behind it is that while there has been a lot of progress towards the EOSC ecosystem over the last years, sometimes it has been fragmented. So the idea is to further consolidate this together, to collaborate, to bring communities and resources together across domains and across these multiple skills. And the idea is to do this, or we are already doing this, by building on successful outcomes of previous projects, so successful ways of enabling FAIR. So this FAIR is FAIR project that I mentioned, but also other projects and initiatives. For example, the working groups of the former EOSC executive board. And it's also, we're also doing this by collaborating with others, for example, the EOSC Association and the task forces. So we've seen already a presentation of one of the task forces by Wolmar earlier today. Specifically, we're doing it by identifying components for enabling FAIR, like practices, policies, tools, technical specifications that already exist and that are successful elsewhere or in a specific domain or for a specific research output, by identifying them and translating these different solutions or guidelines and frameworks for other domains or for other research outputs. For example, not just data, but also to semantic artifacts, also to software, that sort of thing, and into these other domains. And finally, we are doing this by taking the next step in implementation, by defining the support, the governance, the coordination mechanisms that are required to ensure the continuous or the sustainable function of these FAIR enabling practices in the EOSC and beyond. So the way this is being done, so the project is designed with these pillars of the topics of persistent identifiers. I don't know if you can see my mouse, by the way, but you can see the screen anyway. So, but also metadata and ontologies. That's of course very relevant for you today in onto commons. But also metrics, certification, and guidelines. We've heard various references to this in various talks today. And then across these, there is interoperability, so semantic interoperability, but also technical interoperability, legal and organizational as well, and interoperability with the EOSC ecosystem, and as well as engagement and adoption and implementation is also working across these. And then we've got the usual project management, synchronization packages, and dissemination outputs, communication. But these topics, so persistent identifiers, metadata and ontologies, metrics, and interoperability also are sort of the 4 key topics. And are different expected outcomes, which are being reached through these different tiers that you see here in the figures. And the first one is to have an improved fairness of data as well as other research outputs by coordinating the alignment of FAIR data practices and the implementation of frameworks. For example, for metadata and ontologies, this includes, not exclusively, but some of the things are to have a broader and more harmonized use of semantic artifacts or ontologies in EOSC, and or for example, a framework, a framework for metadata crosswalks and mappings between ontologies. But I'll get back to that a bit later. So as I mentioned, this is done through these different tiers, and I'll go through them one by one now, starting with the integrated use cases. So this is how the project started, and it's still working on this by bringing with partners. So it's integrated use cases because the partners of the consortium bring these use cases from diverse domain communities. So you see the 4 main domains that we distinguish as social sciences, photon and neutron science, life sciences, and then agricultural and food science and environmental sciences grouped together. And so each use case partner acts then as a bridge between the project and one or more of these scientific domains. And they provide the expertise with regards to what are the domain relevant community standards, what are the practices, what's still needed, what are the requirements. And they also help with translating this within these work packages. So what works for them and what can be used for other domains or for generic use. In this way, supporting the adoption beyond the traditional domains or the traditional research outputs. So yeah, this reuse of existing practices is key to FAIR impact, really. So these use case partners, then we bring the proven approaches, the tools, and the solutions. So the ones that are trusted and used by a significant community of domain-specific end users, right? Like researchers in the domain. So in these work packages, so you see here again these four main topics: the persistent identifiers, semantic artifacts, metrics, and interoperability. And in each of these, then frameworks and guidelines are set up. And one example, which has been mentioned today, the Fuji tool that was developed in FAIR's FAIR for this the FAIR assessment. It was developed in a domain agnostic way, and what's happening now in one of the work packages of FAIR Impact is that together with experts from the social sciences and humanities, this tool will be adapted to better take into account domain relevant standards for FAIR. And then hopefully this will also help, getting better results as well. This will then be extended to new research communities beyond the social sciences and humanities through tiers 2 and 3. So you can see those here. So we have the cascading grants and the in-kind support. And the idea is that these will help a wide uptake and compliance with these the FAIR data principles and practices. So they're sort of similar. They're both open calls that you can apply for. And when I say you know, I mean literally you, if that's relevant to you. The difference is that the cascading grants are providing a budget to do work on this, up to 10,000 per project per call. And the in-kind support, it's logical. It's the partners giving FAIR Impact partners giving time to the applicants. Oh yes, and the first call is now open. So, or actually the first set of calls, and I don't know if you can read this, but the main thing here is that there is a website link where you can find more information. So these first two calls have to do with fairness assessment and enabling fair signposting, and are great for content or metadata discovery and consumption. So yes, if that's of interest, do have a look on the website. The deadline is the 1st of June, so there is some time. And then finally, the final outcome is the contribution to the Horizon Europe partnership, meaning basically supporting EOSC readiness through harmonization, synchronization, and alignment. So there's a range of strategic coordination activities taking place, like the technical bridging team and the synchronization force. The technical bridging team coordinates, well, as is clear from the name, technical work, for example, with FAIRcore for EOSC, which you will see Tommi talking about soon, but also other relevant initiatives. And the synchronization force does something similar, except not just technical. So it's building on this. This was set up during the FAIR's FAIR project, and it's building on that, maintaining that, and it's establishing and maintaining the dialogue among various projects and initiatives and actors, in EOSC and FAIR. So it's the project also actively engaging with stakeholder communities, so to get the adoption of FAIR principles across. And there's now a group of 12 EOSC FAIR champions that were selected through an open call, and they are acting, they've just started as ambassadors for FAIR. The idea is that they will engage their communities and advocate for the adoption of project results. And they will, for example, organize national roadshows in their country. And that sort of thing. You can find more information again on the website if you want to see if there's anyone relevant near you in your country or in your relevant domain. Yeah, I can't remember out of the top of my head now, but do have a look. So I've mentioned all of this, so I'm not going to go through this one by one. But these are some of the expected key results that we expect from the project. And what's relevant here, I think, is the fourth one, which is a semantic framework for the governance, creation, mapping, sharing, reuse, fairness, assessment, and interoperability of semantic artifacts for EOSC. And that's something that I want to have a look at in the last few minutes. So the metadata and ontologies work package, which happens to be work package 4. The number, of course, doesn't matter. And just as a reminder, so this term semantic artifacts, Jan introduced this already, and it's been mentioned a few times. But just to remind you that this is this encompassing term to include ontologies, terminologies, taxonomies, vocabularies, and so on. And so this work package is focusing on all of these and on making them fair. So they're essential for fairness, but they also need to be fair by themselves. And it will be setting up this semantic framework, including these different things. So the semantic artifact governance, the lifecycle and catalogs, looking again at the minimum metadata for semantic artifacts, setting up a common API for accessing and indexing them, to look at how to make mappings and crosswalks fair, and how to do the harmonization of fairness evaluation of these semantic artifacts. And just focusing on it, first, there will be these, or there are these use cases. These are these integrated use cases, and you see the most important ones here, not all of them. But so again, taking these fair enabling practices from these communities and across research outputs and applying them to other communities and research outputs. So projecting the FAIR principles to also to other types of research outputs than the traditional ones. So, of course, to semantic artifacts, but also research software and crosswalks and mappings. Sorry, the time on my slides has stopped, so I wasn't sure if you were still there, but I think you are, so that's okay. Focusing on one, so I think Maria correctly mentioned that it's not only about metadata to make semantic artifacts fair or anything fair, but that it's an important part. And one of the things that Jan and colleagues looked at in the Fair is Fair project that we're building on now is what are the minimum metadata that you need for a semantic artifact. So, going from if you don't have any, of course, it's not fair. And if you have loads, it's probably fair. But where exactly do you need to be? What is the minimum number? And which ones exactly would you need? And in order to do this, and it was mentioned this morning too, they organized this workshop. And what Barend Mons mentioned this morning as well is FAIR is a lot about getting communities on board. So how do you get a community agreement on something? And this is something that they did in the workshop to establish what are these minimum metadata? What's this minimum metadata schema that you need? So there were 76, I turned it around. Participants, anyway, a lot of participants from a lot of different communities. So I think this is a really good community agreement where this minimum metadata was discussed and voted on, leading to initial DCAT profile using standard metadata properties, enriched with 12 properties from the MOD that was presented there. And the profile formalization is now on its way. And this is something that in Fair Impact we're then building on to extend this first version proposed by Fair is Fair, and using this to define a common API structure that can be implemented in semantic artifact catalogs. Well, actually, I'll go to this. Because beyond that, I briefly mentioned the FAIR mappings and crosswalks, and this is the task that Jan is leading. So I'm sure that if you want to know more, that he can tell you much more about this. But I wanted to show you this, that we have a workshop next week, in a similar way, present what are different communities doing, how are they doing mappings and crosswalks, and what do they need, and how can we make them fair, and to get the community inputs as well. So you're very welcome to attend if this is useful to you. You can sign up online if you go to the Fair Impact website. I can put the link also in the slides actually, because they're distributed. So it's next Thursday. And that was all I wanted to say. So I talked a bit too quickly, as you can hear from my voice. I think I always do this, but then we save a bit of time, so that's good. So thank you for your attention.
Thank you, Pascal. Any question for Pascal? I see a hand raised. Alex?
Yeah, so I have kind of like a comment on the question. So when I see the sectors of research and industry you're covering, they're notoriously there for big data. So social sciences and you know, everything that has to do with a particle accelerator and whatever produces humongous amount of data. So do we see FAIR now the antidote to the big data? Because nobody talks about big data anymore, and that was such a hype.
Yeah, I think it's a good question. I don't have an immediate answer of that. If FAIR is the antidote, I would say not. But one of the use cases, I must say, I'm from the humanities and social sciences, where when we talk there about big data, it's nothing compared to what you have. So not real big data, but for example, one of the other scientific disciplines where integrated use cases come from are photon and neutron science, and I think they have. Well, they deal with actual big data too, like you. So probably it will be interesting to see what comes from there. I don't know, Jan, if you have more of an idea about this from your experience.
Don't think that it's an antidote to big data, because you cannot escape the size of the data you're working with. Whether it's fair or not, I think it doesn't change. However, I think it helps in the process of managing big data and working with it. Because but you get systems, but still having it documented properly, you avoid to have to upload all the data, because you can actually target the one you really need. So you may reduce your burden on big data.
Yeah, because like the reduction is quite interesting, you say, because in our science, come from materials modeling, we were limited a bit to the data we produce, because we kind of like produce live data. And if you had 1,000, that was massive. That's still, I used a SQL database, I must admit, so I went beyond the spreadsheet. But then, of course, the search space is very narrow. So you then make a hypothesis what can go on in your search space, but you may miss out a lot of stuff. And what helped us is now the database modeling. And as the name says, we get bigger search spaces. So we get finally the big data we really want. And then find a different correlation and different search spaces. So this is quite interesting from us. So we always look at with envy in people that naturally have a big data, because somehow we wished we had a big data problem. It's quite interesting, yeah. Thanks.
Yeah, thanks. And it's also, yeah, indeed, as Jan said, maybe even you need it more for big data, because almost if you have small data or smallish data sets with 10, 20, or even 1,000, you know, as a researcher, you can know it, you know your data exactly. You still need to be fair, but you can see it in one go. And whereas if you have big data, you can't. So it needs to be completely interoperable and machine readable. So because you cannot understand it yourself anymore, or know it in one view, if you know what I mean. So, but yeah, thanks anyway.
Thanks, but I think there is a nice opportunity also to collaborate in Commons on the mappings, of course. But there are these open codes that could be also interesting to apply for, where actually there could be practical things that could be implemented linking the communities, because photon and neutrons, they do X-ray diffractions that are used in material science as well. So we could find hooks and links to work together. Any other questions or comments? If not, then thank you, Pascal, again. And then I will leave the floor to the last presentation on what's happening in EOSC with Tommi, who will present FairCore for EOSC, which is a kind of sister project of Fair Impact, or very tightly linked. Tommi, the floor is yours. And you're muted. So we see your slides, but we don't hear you.
Yeah, thank you. Just after I shared the screen, I lost all the controls to make myself visible. So I think you can now see me and hear me, right?
Yes, we can see you and hear you, and I think you can move to full screen. Perfect. We see everything.
So now I have a view of things. All right. Hi, my name is Tommi Suominnen from CSC in Finland. And I'm the coordinator for the FAIR Core for EOSC project. And I will show you a snippet of what we're doing there next. So, as spoken by Pascal, FAIR Core for EOSC is a sister project of FAIR Impact. We are a research and innovation action in contrast to FAIR Impact, that is CSA, coordination and support action. So we in FAIR Core for EOSC are doing very concrete service development work, and FAIR Impact does all the talking and engagement. So we have quite a clear task division in that sense. I'm told that this slide is already slightly outdated, but just to highlight the role of EOSC with regard to the data spaces. Initially, EOSC has been foreseen to be a cross-cutting data space for research and innovation that essentially cross-cuts the sectoral data spaces. It might be, in the end, becoming just one of the data spaces among the others, but it was at least the initial vision. Now, the context for the FAIR Core for EOSC project comes from that the EOSC wrote the Strategic Research and Innovation Agenda in 2021 as a roadmap for what is needed next for the development of EOSC. And based on the issues that were highlighted there, a call was developed for the Commission, to which we answered. And we focus in our project on these 4 topics from the gaps identified in the SRIA. And that is working on the persistent identifiers, metadata and ontologies, on interoperability, and research software. So what we do in FAIR Core for EOSC is essentially we talk of these as components, but we develop 9 new services. The first one is the Research Discovery Graph. Now, this is work that is led by OpenAIRE, and OpenAIRE has already quite a history in collecting together metadata on research objects of different types. So that's publications and funding decisions, data sets, research software. It's pulling all these research objects together. And with the RD graph, it essentially is building a graph that connects those nodes together via different connections that they're able to harvest and discern. Now, the other side of the coin is the PID graph, which is an initiative by DataCite. And in this, they purely developed a graph structure based on the PID-to-PID connections that they have quite well in their a resource of this information, but it is purely between PID-to-PID connections. So it is focusing on the graph technology and will accept only nodes into the graph which have PIDs. So it doesn't try to do author name disambiguation like the RD graph to figure out if Sam Cooke is the same as Sam Cooke or Sam C. Cooke. So this focus is very much on the graph itself, but it does have an API through which you can query, for example, things connected to a specific PID. Now, a service that I will talk about a little bit more in detail is the metadata schema and crosswalk registry. So this is a brand new service that essentially supports hosting and registering metadata schemas, and then it has user interface through which you can visually create crosswalks between metadata schemas. And then we're working on the exact how we will operationalize the conversion by utilizing those crosswalks of metadata from schema to schema. Then additionally, we have the data type repository, and this is essentially a place where you can declare data types, get PIDs for them so that you can refer to them from external sources. The PID meta resolver is essentially a system that allows you to put in any type of a resolvable PID, and it will handle the resolution irrespective of whether that's a handle, a DOI, a URN, or whatever have you. The EOSC PID Policy Compliance Assessment Toolkit is an initiative that takes the EOSC PID policy that has been published a while ago and tries to assess what tools does that policy give to create metrics to assess the different facets of PID policy compliance. And then if that is successful in defining measurable metrics, then it tries to create the tool that will actually perform the measurement of these different metrics for services to assess essentially the PID maturity of a service. Then we have additionally the RAID, which is a new type of an identifier developed by ARDC, so the Australian Research Data Council in Australia. And this is also a metadata envelope that tries to capture information around research activities. The stereotypical use of this would be larger research projects, which are not constrained by a specific funding decision, but can be activities that are spanning 10 or 20 years, funded by multiple funding decisions that is being carried out by a single or a combination of universities, for example. So a larger scale research activity, and to which you can then tie the funding decisions, the organizations involved, the researchers with different roles, and publications and datasets generated. Then we have the research software APIs and connectors, which is related to the next one that I show. So we work with Software Heritage, who is essentially collecting source code on research software around the globe and archiving this. Sort of like you would have the Internet Wayback Machine. This is the source code Wayback Machine. So it archives research source code and issues software heritage identifiers for that source code so that it's referenceable. And with this particular component, it creates new APIs and connectors to new services from which to harvest research source code, including, I believe now, Zenodo and math related, which is having its repositories of its own. So it is able to now access new sources of source code in the context of this project. And then finally, we create the software heritage mirror for the European Open Science Cloud, which will be hosted by GRNet in Greece. So then we have a couple of case studies in our project. We don't have a very strong community focus here, but we have a few case studies essentially to test and give proof of concept to the tools that we develop. The first one of these is the social sciences and humanities through the engagement of Clarin that uses then the components usually highlighted there. Then we have DKRZ, so the Deutsches Klimarechnungszentrum, that is the climate change. So this community will adopt the listed components and show how they produce added value for this community. Then we have indeed the mathematics community. And then we have the National Research Information Systems. So these are national CRIS systems that pull together information nationally on publications, data sets, researchers, research organizations, and so on. And then we have additionally the research data community represented by UDAT. And this is an infrastructure that essentially provides services for storage and discoverability of research datasets. Now I'm going to just very quickly show a few examples of the tools that we're building, and we'll give you a glance at the data type registry and the metadata schema and crosswalk registry. So the data type registry essentially provides a hierarchical model of basic data type descriptions. It allows users to register data types depending on the community needs. They can be as simple or as complex as necessary. An example is, I believe that they have already adopted this for the German audiovisual archive. So all the different audiovisual items that have been deposited there have been data typed in the data type repository. The data type repository provides PIDs for each data type so that you can reference the data type, and a common set of metadata for each of these data types. Now, the DTR toolkit that is being built will allow users to work with the registered types, for example, create validation schemas for the types, explore the different data types and their relations between them. And then I think quite important is also that you can express conversion rules between data types so that you can essentially calculate, let's say that you have a you're measuring temperature and you're measuring in Celsius, so you can press the conversion to Fahrenheit or Kelvin, for example, or a different, more complex equation that allows you to derive data types from each other. A use case of the DTR in the context of the metadata schema and crosswalk registry, it could be that the metadata schema and crosswalk registry request a list of data types from the DTR, which you get returned. You can refine your search. You don't find anything. So then essentially you send a request to create a new data type, and then the DTR can request a new return a new data type to a service that it is interacting with. Now, going into the metadata schema and crosswalk registry, this is essentially a metadata interoperability service. And these are, in short, our primary specifications or requirements, what we aim to achieve with this service. It is a registry to support publishing, discovery, and access of metadata schemas and crosswalks between the schemas. Schemas or crosswalks can be either hosted directly on this service or registered there where they're actually hosted elsewhere. And the main difference here is where are the PIDs pointing to. So if you have your schema just on a web page downloaded from here, thanks, it won't have adequate PIDs pointing to the schema elements or the schema itself. So you can then actually have it hosted on the service so that the PID resolve to the place where the schema is hosted. And yeah, so those are the two main ways that you can have the schemas registered. Then we aim to provide a mechanism to operationalize the metadata conversions by also combining crosswalks. So if you have a crosswalk from schema A to schema B and from schema B to schema C, you should be able to combine crosswalks and have a translation from a schema A to schema C. The platform supports minting PIDs and giving metadata descriptions for the schemas, the crosswalks, and the data types, and making the resources more fair. And then we aim to develop the mechanism and guidelines for communities or individual users to register metadata schemas and create crosswalks between them, and also facilitate projects or research to create and share crosswalk with others that can reuse those crosswalks and then improve them. So do versioning of the crosswalks. And we aim to provide a graphical user interface for visually creating these crosswalks. And it is indeed designed to facilitate the conversion between metadata schemas and integrate the DTR into this metadata schema registry using the DTR API, which essentially means that we can type the metadata schema's elements and attributes using your self-registered data types, and potentially employ the data type converters for format conversion if you map things to each other which don't share the same format. I will skip over this very quickly, but just saying that the implementation will be based on an existing interoperability platform, which already has separate tools for managing the terminologies, so your ontologies, your code lists, which are essentially lists of the natural languages or countries or such, and information models, and a commenting tool, which allows you to have a kind of a governance through which you change and evolve your terminologies and your information models, and comes with a lot of infrastructure ready, such as all the GUI components and such. So we don't start from scratch when we're developing this service. And what we essentially want to add on top of these existing functionalities is the dedicated crosswalking tool and the integration for DTR. How exactly we will operationalize the crosswalks are still a question that is open. So they need to be actionable, but whether you download it and run, let's say, a Python script on your own computer, if we generate the code to operationalize the crosswalks, or if we deliver a container that you can then put on your own service, this is still unclear. And this is something we will work on in the future. So the FAIR Core for EOSC project is a conglomeration of a lot of partners, but at the same time, we are just one project among very many. So in the Horizon Europe, there are quite a few EOSC projects working on furthering and further developing EOSC. And if you would like to find out more about our project, here is a link to a 1-hour webinar that you can watch that gives you a more detailed overview of our work. And with that, I'm at 60 minutes and 50 seconds. I'm sorry for being a bit over time, but thank you very much.
Thank you, Tommi. Actually, you still had 5 extra minutes, so so you're actually perfectly on time because we were slightly late due to the technical issues. So any questions from the audience? I see a hand raised. Can't see who. That's Alex. Alex.
Yeah. Hello, you did a very good talk about data. So obviously I have to ask you about software because I noticed that your project is planning basically to preserve research software. What makes this different to places like GitHub? Why would I come to you and not to GitHub?
Of course, this is being this work carried out by our project partner in France, Software Heritage and INRIA. But I am aware that there are, I think, hashes in GitHub that point to a specific version of the source code. But the thing is that, like we saw with, for example, SourceForge, these are services that can come and can go, and we can't ensure their sustainability over time. And when you refer to a source code, for example, in a journal article, you have to be do at least your best effort to ensure that that source code would be available at some point in the future if someone wants to reproduce the results of your paper. So the Software Heritage plans to be a persistent place where specifically research-related source code is archived. And essentially, you can see it as a backup to GitHub in that sense that this should be a place where it's as persistently discoverable as is possible. Mm-hmm. It also provides the PIDs to identify that should resolve to the place where the source code is hosted. You can also give your GitHub link, and I don't say that you shouldn't, to your repository where the source code exists. And I'm sure in the paper there is a way to also point to the specific version of the source code that was used in a specific article. But in GitHub you can also delete code and edit it afterwards. And this is trying to get the same kind of certainty and referenceability for versions of source code as you have for scientific papers, for example.
So basically, what you give me then is a Wayback Machine for code.
Yes.
Okay. Yeah. Now it's interesting that you say, because there's a lot of research software that is kind of like developed for a project and then forgotten, and then obviously there is a link to some web page to some academic that doesn't exist anymore, and then I read this paper and I have no idea, and then you tend to recode stuff. Yeah. So this is a big problem, because some people tell you, oh, it's so easy to write for me some piece of code, so I just do it because it's just my second nature, rather than to kind of reuse, then cite where it comes from and then improve. So I think that's a good idea, because we often talk in software about legacy. What's my legacy? You see, so if I then can be preserved for all eternity, like I can preserve an article, it's a good legacy. Yeah, thanks for clarifying.
Actually,
it's a good idea.
I'm getting, of course, more ideas as we talk. So the other thing is, of course, that with the PID graph, we have information on the correlation between, let's say, source code versions that allows you to express that this, you cite a source code, but essentially you're citing a later source version of the source code than in your previous paper. So then we can form these kind of semantic connections between source code instances that say that this is actually a later version of this source code. And then you can essentially aggregate citations to a specific source code if you know that the source code instances that you have referenced in the last 1,000 papers in the community, that they're actually related, and essentially they are pointing to the same software, even though the identifiers are different, if you know that the identifiers are related semantically.
Yeah, and that's a good point, because we had sometimes different version issues from academic, and then you ask your student to do some calculation, and then the rounding is different, and then you blame them, they have done the wrong stuff, but they haven't. They just used another version. Then yeah, I can see the intriguingness of it. Yeah, awesome. Yeah, thanks for answering a question that had nothing to do with data but software. Thank you.
Also, something that you need to know, Alex, is that GitHub changed their policy. So they're trying to clean up all the unused repository, old ones that haven't been accessed, because at some point they need to make room. So if you have code that you created maybe 10 years ago on GitHub, at the beginning of GitHub, there is a good chance that if no one visited it, it's gone.
Yeah, no, it's a good point that makes you think, because I work with this Software Sustainability Institute in the UK. Yeah, have sometimes interaction, and it's a good idea to point this out, because I will tell them about this. Because they big on legacy, so they big on the research software engineer who does software for research and whatever. And I think it's an intriguing point when we go beyond version control, when we really can go to the actual version in a repository where this is. You also find this often in some industries where software owners have to keep a previous version. Some industries we may not mention here, very, very notorious, because they go back for checks. They do, for quality control and God knows what. Yeah. So I think this could make software for some instances very, very attractive, because you can always go back to where you were, and that sometimes for legacy issues are really, really important. Yeah.
Maybe this could be a very good motivation why the European Union should create a what we call an own version of GitHub, more or less, that is not externally controlled and can have different rules when it comes to maintain or functioning as a functional escrow for programming code and other kind of components.
Thanks, Dan. Any other questions? Maybe I can make a comment. I've heard during the presentation yesterday that there was a huge interest in the OntoCommons communities on fair mappings, actually. We heard that also with Roche this morning. I think it's a key aspect for any of the semantic platforms we're developing. So I think there would be room for collaboration with both Fair Impact and FairCore for EOSC that we should consider, so that actually the partners in OntoCommons can feed in also requirements in these ongoing projects, so that we can integrate also this kind of inputs. Because of course it's based on EOSC, but it's not only science. Material science is science, actually, right? So we should start considering it. Thank you very much, Tommi. You are concluding actually the session on EOSC related project. Thank you all for presenting. Now we're going to have a short